So in this podcast, we're going to look at graphing rotations. Right? So first, when we don't have a coordinate plane, right, we have to use constructions or some ways that we can figure out how many degrees something is turning. When we have a coordinate plane and we're rotating around the origin, we can use the coordinates to help us figure out where to go. Because our coordinates are signed, right? They have, each of the quadrants has a different sign, and there's 4 of them. So when we rotate 360 degrees, it means we're going to go through all 4 of them. And if we're not going 360 degrees, then maybe we're going through 1 quadrant or 2 quadrant or 3 quadrant. So we have some rules that we can use to help us, so we don't have to always try to visualize where something is going to go on a rotation. So a way to remember the change in position for a rotation is the following. So determine how many quadrants the figure is moving. If you're moving 90 degrees, that's going to be 1 quadrant. If you're moving 180 degrees, that's going to be 2 quadrants. And if you're moving 270 degrees, that's going to be 3 quadrants. Okay? So notice here our quadrants, if you notice my little tiny sketch, oops, come on. There we go. Little tiny sketch there of a little coordinate plane. All right, so it has the signs there. I'm trying to get rid of that box there. There we go. So in the first quadrant, everything is positive. In the second quadrant, right, the x values are negative, but the y values are positive. In the third quadrant, everything is negative. And in the fourth quadrant, the x values are positive and the y values are negative. So we can mark the signs for x and y based on the signs for x and y of the quadrant. Every quadrant, the x and y coordinates switch. The x and y coordinates are switched for the image for a 90 and 270 degree rotation. So every 90 degrees, x and y switch. 180 degrees, they switch back. 270, they switch again. And so every 90 degrees, your x and y coordinates are switching back and forth. And I'm going to show you that on a rotation around the origin. For a 180 degree rotation, the coordinates switch and switch back. So the coordinates are the same, but the signs will be the opposite. So for instance, if the object was here in the first quadrant and it rotates 180 degrees, whether it's clockwise or counterclockwise, it's going to end up here in the third quadrant, where the signs are both negative. So we can use the fact that the quadrants have different signs to help us figure out the proper coordinates. I also have another way, if you like to, if remembering rules are more your thing than trying to visualize which quadrant you're moving to, I also have some rules you can use as well. All right, but one way is visualizing what quadrant you're going to. Okay? So another way you can think of a 180 degree rotation is that it's like 2 reflections. So both the x and the y coordinates will be the opposite. All right, so here we are rotating around the origin. All right, so the blue triangle there is the pre-image. I chose 1 point, and that was the point 1, 2. And what happens as our triangle rotates around? Right? So notice it's going around in a circle. Right? And so as it's going around this circle here, our horizontal and vertical distances are changing. Right? So here, I've just picked on that one little point. Right? It has an x value of 1, so the distance is 1 from the along the x coordinate, and the distance is 2 along the y coordinate. Well, as it rotates, right, it goes around the circle. And notice now that those 2 have switched. So now the horizontal distance is 2, and the vertical distance is 1. Right? The only thing is that in the second quadrant, x is negative. So instead of having a positive 2, we have a negative 2, because the values are negative in that quadrant. As our triangle is rotating around the origin some more, the coordinates are going to switch again. So now notice that again the horizontal distance is 1 and the vertical distance is 2. Right? And then we're going to switch one more time. Right? And now the horizontal distance is 2 and the vertical distance is 1. Right? But notice the signs change because the values in that quadrant change. So here in the third quadrant, instead of having 1, 2, we have -1, -2, because x and y are both negative in that quadrant. Okay? Right, so notice that, watch how the horizontal and vertical distances change as the as the figure rotates around the origin. The numbers in the parentheses represent horizontal and vertical distances from the origin. Oops, the other half of my sentence is not being shown here. Come on, move up. It always seems that the first time I try to move anything on a podcast, it moves so slowly. There we go. Notice each time x and y distances, coordinates are switching. Right? So we can use the fact that the horizontal and vertical distances are switching, right? And that in every quadrant the signs are switching to figure out what the coordinates are. I don't know why that won't move up. All right, so notice that signs are opposite in diagonal quadrants, so we switch the signs. Okay. All right, so we can also rotate around a point on the figure. I'm going to focus in this lesson on rotating around the origin, but the idea will be the same if we're rotating around a point on the figure. And actually, we can just draw a little coordinate plane for us with the center of rotation being the origin, and then just you ignore the coordinates and just count the distances, because the coordinates won't mean anything if I'm not rotating around the origin. All right, so we see a figure can move around a point on the coordinate grid, typically the origin, but we can also rotate around a point on the figure itself. When a figure rotates around a point on the figure, one point on the figure is stationary as the rest of the figure turns. So you can think of a basketball player pivoting as one foot stays planted. Right? So the figure's turning, but one point staying put. All right, so I also have this in your notes. Right, so if it's easier for you to remember rules, right, I have the list of rules here for each of our rotations. If you forget the rule, though, remember you can figure out how many quadrants you're moving. Right, move to that quadrant and then look to see what the signs of the values are, of what x and y are. Right, and that's another way. So you get kind of a visual way you can figure it out, and you've also got a rule-based way, right, and they both work. So in general, we can state the following coordinate rules for counterclockwise rotations about the origin. Right? And I've also added in a little bit about the other way, clockwise. Right? So a rotation of 90 degrees counterclockwise. And so let me kind of help you visualize this here. Let's give ourselves a coordinate plane. All right, there we go. All right, so let's say I'm in the first quadrant. There I am. All right. So if I go 90 degrees, right, then I'm going to be in this quadrant. Right? And actually, my x would be facing this direction. Well, yeah, it's kind of hard to draw a sideways x. It kind of looks the same either way. But imagine that's sideways. Right? So the x is rotating around the coordinate plane there. Right? And so if I rotate 90 degrees counterclockwise, right, I'm going to, so if this was over here, we were xy. Right? The coordinate distances are going to switch. Right? So now, whatever the y value was, that's going to be my x value. And the sign is going to be the opposite, because the x's are negative in that quadrant. So xy is going to go to negative yx. I have some writing in blue here. I have everything else in your notes except for the blue writing. If you could add the blue writing to help you remember. Right? So the new x coordinate is going to be the opposite. Right? So the old y coordinate becomes our new x coordinate, and that x coordinate is going to be the opposite. So all of this down here, you should add to your notes. Right? Right? So now 180 degrees. Right? Coordinates are going to switch back again. Right? So now they're going to go back, but this time both of them will be the opposite. So they'll be the same values, but the signs will be changed. Right? So a rotation of 90 degrees, 180 degrees counterclockwise or clockwise, right? We'll have our x and y coordinates staying the same, except the signs becoming the opposite. Right? So it doesn't matter if the rotation is clockwise or counterclockwise, you end up in this exact same location. So it doesn't matter which way I go around the circle, I'm going to end up in the opposite quadrant. And then 270 degrees counterclockwise, the coordinates are going to switch back again. Right? So now I'm kind of facing sideways again, right? Coordinates will switch back again, right? But now the y will be positive and the x will be negative. Oops. Right? Because the y values, and this is the old x is our new y, right, will be negative in that quadrant. Right? So the signs are based on the signs of the quadrant, and we have some rules to help you remember it. Right? So 270-degree counterclockwise rotation, the new y coordinate is the opposite. Right? And when we say opposite, it means that positive becomes negative or negative becomes positive. Right? So the opposite sign. Right? And rotating 90 degrees clockwise is the same as 270-degree counterclockwise. So whatever the rule is for 90 degrees counterclockwise is also the same rule for 270 degrees clockwise. And 180 degrees doesn't matter which way. The rotation set 270 degrees counterclockwise is also the 90 degrees clockwise rotation. Right? Just go in the other direction. Right? So rotation of 90 degrees clockwise is equivalent to a rotation of 270 degrees counterclockwise, and a rotation of 270 degrees clockwise is equivalent to a rotation of 90 degrees counterclockwise. All right? So add this to your notes. Of course, you can pause the tape. You don't have to wait around for me. I'm going to continue on, but you can pause me and you can write these down, and these will help you. Okay? You have the typed part in there. It's just the handwritten part. And maybe my little graph here will help you see what the coordinates should be. Kind of attaches some meaning to those rules. Okay? So let's do some rotating. All right, so this example, I think this is the example in your notes. I don't have it right in front of me, but I believe it's this one. All right, and if so you're going to do this one along with me. So we're going to graph quadrilateral KLMN. Right, so the first step we're going to do is we're going to graph the quadrilateral. The vertices are 3, 2. So that's K. 4, 2 is L. 4, -3, right, oops, here. Sometimes it's hard for me to see the coordinate plane up here. And yeah, that would be M. And then 2, -1, right there, is N. Right? So I'm just going to connect K, L, this is a vertical line here, M, N, and back to K. There it is. Right? So there's our quadrilateral graph. Right? And we're going to rotate the quadrilateral 270 degrees about the origin. Right? So and it's clockwise. 270 degrees clockwise. Right? So we're going, this time we're going to go, that's 90. That's where where you saw that dot come. 180 is where that dot is, and 270 is where this is. So notice that where the M and N are, right? So they're in this the fourth quadrant over there. They're going to move up here. So M and N are going to be in this quadrant. Right? And when the K and L there goes 270 degrees clockwise, those dots there, it's going to go 1 quadrant, 2 quadrant, 3 quadrant. So K and L are going to be in this quadrant. Oops. Whoops. Put the eraser in the wrong spot. K and L are going to be in this quadrant. Okay? All right, so for 270 degree rotation, right, our signs are going to switch. Right? So I'm going to have actually I'm going to write in a different color here. I'll write in red. My figure will be red. Right? So the 2 and the 3 are going to switch. What's the sign? So you have 2 ways you can figure that out. Right? You can either figure out which quadrant is going to and look at the sign of that. So notice here, K is going to the second quadrant. This is the second quadrant, where my X is negative and my Y is positive. Right? So that means the first value is going to be negative. The other way you can remember it is if you go back to your rules here. Right, so 270 clockwise is the same as 90 counterclockwise. X and Y switch, and the new X coordinate's the opposite. Right? So whatever way is easier for you to remember, that's the way you should use. Right? And you can always, if you're doing classwork or homework, whatever, refer back to those notes. Okay? All right, so now for 2 we're going to switch. Okay? And the new x is going to be negative, so that'll be negative 2, 4. For negative 3, switch. Right? And then the first one's going to be the opposite. So instead of a negative 3, 4, we're going to have a positive 3, 4. And if we think back to what quadrant we're going to, right? M is going to the first quadrant where both x and y are positive, right? So of course those values are going to be positive. And n here, the coordinates are going to switch, and the first one becomes positive, right? Because it's the opposite. It was negative, now it becomes positive. Right? So we can use our quadrant to help us figure out the signs, or we can use the rules to help us figure out the signs. Either works just fine. All right, so let's graph this. All right, so k is at negative 2, 3, and negative 2, 4. I should probably mark that. That's k prime, l prime. M prime is at 3, 4, right there. That was m prime, and make sure you're putting this in your notes. And then n prime is at 1, 2, right there. And that was n prime. All right, so let's connect our points. Remember to connect in order, right? You don't want to be going all over the place, right? And you can look to see what was the order, right? So it's k and k to l, right? And then l to m, and then m to n, and then go back to k. Right? So notice that the part that was in front before, m here, I kind of like to think of it like, like traveling in space here. So this part here that was in front before is still in front, right? It's still leading the path, right? It doesn't flip around, like it's a fish out of water, right? It's going around in a circle. Now it's not reflecting, it's rotating. Okay? And that's all we have to do. So if you use the signs of the quadrant, if you think about where it's going to go, take a moment to kind of plan it out, figure out where you're going. That'll help you get the right quadrants. And then step back and look. Does it look like a rotated figure, or is it just going all over crazy? And if it doesn't look right, then go back and start over and fix it. All right? All right, let's look at another example. All right, so ABCD is rotated clockwise about the origin through 90 degrees, right? And there we have our points, right? And 270 degree counterclockwise, 90 degree clockwise are exactly the same, right? X and Y switch. Now the second becomes the opposite, right? And if you're having trouble remembering the rule, then I can think which way it's going. Right, so it's going 90 degrees clockwise, right? It's going right here. This is the third quadrant. Excuse me, the fourth quadrant. Yep, come on. Well, that helped. I guess because I have the pen still in my hand. This is the fourth quadrant right there, right? And in the fourth quadrant, the x is positive and the y is negative, right? So, and the whole figure here is in the first quadrant. It's going to go 90 degrees clockwise. It's going to end up there. So the y value has to be negative because all the values are negative in that quadrant, and it's going 90 degrees. All right? So when we rotate 90 degrees or 270, we switch the coordinates. All right? So A prime is going to be, we're going to switch the 3 and the 1. So now instead of 1, 3, it's 3, 1. Second one becomes the opposite. B prime, switch the 5 and the 1, so it's instead of 1 to 5, so now it's going to be 5, 1, and the second one's the opposite. Switch the 4 and the 5, right? So now it'll be 5, 4, and the second one's the opposite. Switch the 6 and the 3, and the second one is the opposite. Once we have our points, it's easy to graph. Always figure out your points first, right? Don't try to mentally rotate it. Right? It's kind of difficult. Right? Use some things to guide you because you know those distances are switching every 90 degrees. Okay? All right, so we have our point 3, negative 1. It's right there. That is A prime. B prime is at 5, negative 1. C prime is 5, negative 4. and D prime is at 3, -6. Okay, and here's our figure. Oops. Oh, that's a nice straight line. Let's see if I can get that out of there. Nope. Well, it moved far enough for me. I'll take care of erasing it later. That's a little bit better. Oops. I went too far now. There we go. If we get rid of this, go any day now. There we go. And we clean up that, because this is supposed to intersect right there at 3, -6. There's D prime. Right? Probably should have moved my letters up a little bit, but I don't know if they're going to move or not. Oh, there we go. If I just put in a new point there, there we go. Now it looks a little bit better. Now my points aren't in the middle of my figure. All right, so there we go. There's our figure rotated. All right, so all we had to do was switch those x and y coordinates, and the second one becomes the opposite because y is negative in the fourth quadrant. And you notice we're keeping that circle, right? We're keeping the circle. I'll just have to hand draw it. We're keeping this circle, well, not a great circle, but you get the idea. We're keeping that circle as we rotate around, right? And the horizontal and vertical distances are changing. And what was in front before, D, is still in front, D prime, as we rotate. Let's look at another one. And this is the same figure, 180 degrees, right? So ABCD is rotated 180 degrees about the origin, right? So now 180 degrees, this is 90, this is 180, this is quadrant 3, where both x and y are negative. So signs will be the opposite. Right? So the distances aren't going to change because they would have switched and switched back, but the signs will be the opposite. So A prime is -1, -3. B prime is -1, -5. C prime is -4, -5. And D prime is -5, -3. Right? And now we'll graph those. So -1, -3 is right here, A prime. B prime, -1, -5. C prime, -4, -5. And D prime, -5, -3. Okay, and now here's our figure. And on a 180-degree rotation, it's going to look like you reflected twice. Like you reflected once over the y-axis, and then again over the x-axis, right? So 180-degree rotation does look like that. And there we go. There's our rotated figure. That's all our rotated figure. That's all there was to it. Ooh, that doesn't look good. My point and D are very far away from one another. Yeah, let's just do that. Yeah, good enough. I'll make it look better before I post this. All right, so let's look at the next one. Oh, this is just boy, my points are just not where that just looks so sloppy. Maybe I should wait to write my letters in till after I put the figure in. There we go. That looks a little bit better. We'll get rid of that, and we'll get rid of all that. There we go. Ah, beautiful. I bet there's a 270-degree rotation on its way. No, I didn't do the 270. I just did the 90 and the 180. But quite honestly, the 270 looks just like the 90 going the other direction, right? This whiteboard practice will be moved to a classwork coming to you shortly. All right, so we're going to look at one last thing. Oops. And actually, I think I'm going to end this podcast, and I'll pick up in the next podcast. Right? So 3 podcasts for this lesson, but this next one is short. All right, so bye for now.